So good afternoon. My name is Nicholas Alberti. I'm from the Advanced Computing Group of the Frost Institute of Data Science and Computing. I work there as a Linux system admin. I work under Ravi, our Director of Advanced Computing, and my colleague Elvis, who's an assistant scientist. This is going to be the first of many training sessions that we're going to be hosting across a few semesters. This one is tailored more towards those beginning to use our advanced computing resources and services. So things like the supercomputers, Trident and Pegasus will introduce to you what our group is about, our capabilities, our expertise, how to request projects and groups, differences in our services. So I'll hand it off to Elvis to get started.
Thanks, Nick. So to introduce advanced computing services, I feel I have to introduce the Frost Institute for Data Science and Computing, commonly known as IDSC. So IDSC is a member of the university's Frost Institutes of Science and Engineering. The Frost Institutes were announced about 7 years ago, following a gift from Philip and Patricia Frost. The goals of IDSC are to enable enable discovery through data-intensive research, and to enhance data science understanding among our students and the public. As of the 8th of March this year, we have moved to a new location at 1552 Brescia Avenue. This is behind the Newman Alumni Center. We've included a map and a picture to assist those who may be interested in a physical visit. The Advanced Computing Services is a part of IDSC. We manage the university's supercomputers. We're comprised of operations and research support. We support several user groups across science, engineering, medicine, and the liberal arts. We collaborate with IDSC's systems and data engineering team to provide a comprehensive set of services and training opportunities to users. I'm now going to talk about IDSC Advanced Computing Services. More specifically, I'm going to cover hardware. I'm going to describe the team that makes up ACS. I'm going to talk about services and opportunities for new and current users. So the hardware, we essentially have two supercomputers, Triton and Pegasus, and both of them are housed at the Equinix Network Access Point data center in downtown Miami. The data center is the six-story building that you can see in the slide with the three spherical objects on the roof. Triton is the newer of the two supercomputers. It comprises 96 IBM AC922 servers. These are designed for data-intensive workloads. Each server includes 40 cores and 2 GPUs. There is a special connection technology from CPU to GPU and from GPU to GPU called NVLink, which allows this AC922 server to be faster than comparable servers using a computing technology known as PCIe. This is particularly true when large amounts of data need to be moved from the CPU to the GPU, as when occurs when a large model is being trained on, let's say, large high resolution images. In such cases, the AC922 server can be, nearly 4 times as fast as a comparable server using the competing PCIe technology. The older of the supercomputers is Pegasus, and Pegasus consists of 350 Intel Xeon servers. Each server contains 16 cores. We can talk about more specifics in the Q&A. And then I am going to talk about the team that makes up Advanced Computing Services. I'm going to start off with the leadership team. We have Ravi Vadapali, who is the Director of Advanced Computing Services. He has over 20 years of experience in advanced computing and data science across several disciplines. We have Warner Beringer, who is the Assistant Director. He has extensive experience in advanced computing systems. The rest of the team includes Rajesh, who's in the audience. He has expertise in cybersecurity. Myself, I have expertise in computational chemistry. Nicholas, he has expertise in systems administration. Dimitri, who isn't here, but he has expertise in Linux systems admin. Eric has expertise in systems admin, and Pedro, who is a senior applications developer at the Sylvester Comprehensive Cancer Center, and is effectively a liaison between Sylvester and Advanced Computing Services. I am now going to cover services that are available through ACS. I'm going to talk about high performance computing and storage, then data analytics and data science, and then research facilitations and application support, and then, user training. And then, so I guess I have to define like what high performance computing is. So I've talked about Triton, I've talked about Pegasus. So clusters such as Triton and Pegasus use basically clusters of powerful processors working in parallel to process large data sets and to solve complex problems at high speeds. You can use HPC in any case where you need to process data or compute using data. Cases from disciplines ranging from healthcare to climate modeling. The advantage of using high performance computing is that you usually solve bigger problems than would otherwise be possible. You also can solve problems faster, which allows you to, save time and money and solve more problems. We offer two types of storage. We have active storage that is attached to the high-speed network and is connected to computational resources. It supports what we call scratch space and project space. We can talk more about those in the Q&A. It costs $500 per year for 10 terabytes. And then we can talk about details in the Q&A. We also have a passive or archival storage. This is slower access, but it's less expensive. It's not attached to computational resources. It costs about $300. It costs $300 a year for 10 terabytes. We also offer data science and analytics support, including how to deploy data science workloads on our hardware. We offer research facilitation and application support. By research facilitation, we mean that we support the translation of science inquiry into computational research and training. And by application support, we mean that we assist with configuring, installing, and optimizing software on our hardware. We also offer user training, and here we have two tiers. We have a basic tier for new users. This includes HPC onboarding, software and data setup, as well as guidance and troubleshooting to get new users started. For users already onboarded, we have a more hands-on assistance service available. As far as software is concerned, we offer a variety of codes. This is only a selection of the several that are available. We also offer interactive programming environments, including Jupyter Hub and RStudio. We offer data processing tools, and for those interested in their own software development, we offer numerical libraries as well as compilers for C, C++, and Fortran. All right. So I'm just going to describe opportunities for, I guess, different sets of users. I'm going to so there are opportunities for research and internships for students within ACS. And there are also fellowship opportunities available through IDSC. I'm going to talk about opportunities for faculty, support for specialized projects, and support for grant collaborations. And then, lastly, I'm going to talk about, the opportunity for user training. So I'm just going to, I guess, share like the students who are currently working with us on a variety of research projects. So we have three undergraduates currently working with us. We have Grady, Suban, and Talia, who are all from computer science, but are working on projects, that suit their individual interests. We have two graduate student interns, Jesse and you, who are working on data science / data analytics. Data science / data analytics research projects. And then I will include the IDSC fellows as of the end of last year. And they were three. So there is Anna and Christian, who are working on genomics related projects. And there is Jeffrey, who was working on a project on curing paralysis. So faculty have the opportunity to inquire about specialized project support. We work closely with the systems and data engineering team, and we can provide support for special projects. To request or inquire about such support, you can contact us at hpc@ccs.miami.edu. You can also inquire about support for software engineering/development projects. I've included some links to the relevant pages where you can get more information. And faculty can also inquire about grant collaborations. We can help faculty identify the resources, the grant programs, as well as potential collaborators. And then lastly, I'm going to just show you our plan for user training for the rest of this year. So we have Advanced Computing 101 today. Then in the fall, we're going to have a hands-on computing session that is going to cover a serial shared memory computing. And then we're also going to have a containerized workflows using Aptainer training session. And then we will probably have workshops that will cover some aspects of parallel computing, including distributed memory computing. That is the first part of this presentation. I will turn it over to Nick.
Thank you, Elvis. So this next part of the presentation, we're going to focus on connecting to and utilizing the supercomputers. We'll start off with SSHing into the clusters and then transferring data using FileZilla. Then we'll talk about navigating a Linux file system, how you'll move around the supercomputer, look at the files, things like that. Then we'll talk about storage, then how to use software, processing jobs through LSF, and the specific use you can use with LSF. So let's talk about connecting to the cluster. So we access it using a command called SSH. This is a secure shell, a network protocol that allows remote access through an encrypted connection. So essentially, your laptop here is connecting to a secure Wi-Fi network. If you're faculty, that's probably you, Miami Wireless. If you're a student, that's CanesNet. Then using that secure network, you're going to use the SSH command to get into the login node. And then here you have these compute nodes. These are just worker nodes that are used for their resources to process your jobs. Well, let me see what happens if I open this link here. Oh, okay, great. So this is the respective documentation for this section. This tells you all you need to know about connecting to Trident and Pegasus. We're just going to use SSH for this presentation, but if you're interested in using PuTTY, you can download and configure PuTTY for Windows using these configuration settings here. Oops. Usually you will use this command on a terminal or command prompt to connect to the cluster. It's the SSH command, followed by your username, and then the server name, so Pegasus or Trident. And we'll go over that in a brief demo. Let me go back. Okay, so this is the first part of the demo. If you are on campus, you have to be connected to a secure network, as I previously stated. That's you, Miami Wireless, or CanesNet. So the next part is if you're on a Mac, you're going to open up an application called the terminal. It looks like kind of like a black window. If you're on Windows, you're going to open the command prompt. So let's go ahead and do that because I am using a Windows machine. You can always type in the search bar here too and type in CMD and it'll pop right up. So our command prompt is open. we can just invoke SSH followed by your cane ID at, and then we'll connect to Trident for this presentation. Enter, it's going to ask you for your password. And you've logged into Trident. It's as simple as that. Let's see. So the only real difference between connecting to Trident and Pegasus is Trident, you are going to use your University of Miami password. If you're connecting to Pegasus, you'll have a specific Pegasus password that will help you set up before you even attempt to connect. So off-campus connection requires you to download and install the Global Protect VPN that's hosted on UMIT's website at this link. They have instructions there on how to download and configure, but it's very straightforward. One thing to note, a very recent VPN change is that you will need a UMIT commissioned laptop to connect to the VPN off campus. So if you don't, you won't be able to connect to the VPN just yet. But I believe this is a temporary policy that might be changed soon. Once you download Global Protect, it's going to give you a URL. You're going to put this into the URL and you've connected to the VPN. It's very straightforward. I don't have the application installed on this laptop, but if you take a look at our documentations in the access section from before, there are details on how to do that there. And after you've installed the Global Protect client for the VPN, it's the same exact process. You're going to open a terminal or command prompt, and you're going to run the SSH command to connect. Okay, so we've connected to the cluster. Let's talk about transferring data. So there's a couple ways to transfer data. Advanced computing supports multiple file transfer programs like SCP, rsync, but probably the most used and easiest way is to use this application called FileZilla. And here is just some more details. And if you're interested in using SCP and rsync, these are the commands that you can run on your local machine to transfer those files. But we also, at the bottom here, include a direct link to download FileZilla as well as a guide. You can also just Google it, FileZilla, and it'll be the first thing that pops up. Very easy to install. You just run the installer and the application installs. It looks like this. I'll run through a quick demo on how to transfer some data. Let's see. Okay. So once you open the FileZilla application, it looks like a lot, but it's pretty easy to understand. The left side is going to be your local machine and all the files and folders native. And then the right side is going to be the remote server. So this is going to be your Trident or Pegasus directories. Up here, we're going to set the connection details. So for this example, I'm going to connect to Trident. Let's input the full DNS name of Trident, trident.ccs.miami.edu, followed by your credentials. And port 22. You hit quick connect. If it asks you for a server host key, you can just click OK. And you'll see now on the right side, I'm connected to my Trident. Right now, I'm on my home directory. Transferring files is as simple as dragging and dropping them. So I'm just going to pick this random Word document and I'm going to drag and drop it to my home directory. And you see down there, it gives me a prompt telling me that the file is successfully transferred. I can confirm it with this tab down here. It tells me my source location and the destination remote file location that it now is residing in. And you can do this with folders, files, anything you need. It's as simple as dragging and dropping. All right, let's continue. Okay, so now we've connected to the cluster and we've transferred our files. Let's talk about navigating the file system of Linux. So this is CentOS 7 based Linux. We use a command line interface that interprets the commands you type at the command prompt. You could pass flags, arguments, and it spits out some result. You use these commands to traverse the file system. So you want to change folders, you want to move folders, you want to list the contents of a folder. These are the specific commands you can accomplish that with. We have a Linux guide for those who are not familiar with utilizing Linux, commands on how to navigate the Linux shell, interacting with files, and file permissions and control lists if you're really interested in that. So this is what the command shell is going to look like on both Pegasus and Trident. Very similar. It's going to start off with your user, which is going to be the KNID, at the specific machine you're logged into. In this case, it's going to be login 1. This is the login node. And then followed by the current directory you reside in. Directory and folder are the same exact thing. I'll use them interchangeably through the presentation. And then here's where you're going to input your commands. These are some of the most basic navigational commands for Linux. You have cd, allows you to change into a directory. pwd lists the full path of your present working directory. ls will list the contents of a directory. mkdir, you can create a folder, and mv can be used to move and rename a file or a folder. So this is a quick little demo on how to utilize some of those commands. Let's see how we're going to do this. Okay, I think I can have this side by side here. Can everyone see the command prompt okay, or is it too small?
It's visible.
All right. Okay. So first thing I want to do, I've logged in to my home directory. You see NRA20, which is my KNID at login1. I want to list my current path. Let's see where I'm at. Right now, I'm in home directory, home NRA20. That's my present working directory. I want to switch into, let's say, my project's Scratch folder. I'm going to use the cd command followed by the path to my Scratch folder. Usually when you apply for projects, we provide this path to you, so you don't, have to be guessing or anything like that. Okay, so as you see, this directory location changed to AC projects because now I'm in the AC projects folder. ls will show us the contents of that folder. These are all the other folders and files that live in this area. So now I want to make a new directory. You can use the mkdir command followed by a name for your directory. Okay, now I'm going to change into that folder that I just made. And now I'm in that new folder. So let's say you've navigated the file system quite a bit and you've gone through a rabbit hole, you don't really know where you are. You can always just type cd followed by no parameters and you go right back to your home directory. So that's kind of like I guess a safe point for you to always go back to. Okay. So now I'm going to create a blank text file and I'm going to move that file from my home directory to that new folder that I just made. I'm going to use the touch command. This just creates an empty blank text file. Then I'm going to use the mv command to move that text file to my new folder. And you have to be sure to put the full path to the folder. It's called the absolute path. Okay, so now I'm going to change into that folder and make sure that it's been moved. So I type in ls to list the contents. You see the file has been moved to this folder. Now, if I want to rename it, you can use the same move command. Move followed by the name of the file to be renamed, followed by its new name. Use ls to confirm, and it's been renamed. So those are just some very, very basic navigational commands that you'll probably be using to get through your Scratch folders and your home folders and things like that. Okay, now let's talk about storage. So we've connected the cluster, transferred the data, and we know how to navigate the file system. Where are we going to put this data? So we offer two types of storage. Elvis went over a bit on the cost-effective storage. We'll focus more on GPFS storage for these few slides. The GPFS storage is storage directly attached to the supercomputers. This is where you can store active data. It's attached to the high-speed network, and it's very suitable for computational support. We have more information here on this doc. If you want more details, I have a few more in the following slides. So these are the different types of GPFS storage. I'll break it down. So you've got your home folder, and your home folder comes automatically with 250 gigabytes. You can use it for software installations. If we don't have something available already on Pegasus or Trident, you're free to install software in your home directory. You can store a small amount of data in there. This purging, we'll get into purging in a little bit. Let's skip that for now. Home directory is accessible only to you. This is your private space. Nobody else can access it but you. On Trident and Pegasus, these are the paths to your home directory. And home is included when you request a project and you receive an allocation for either Pegasus or Trident. This always comes with it. Scratch is another one that's also included with every project. You get 2 terabytes used for active input and output data. So any staging data that you're going to be using to run jobs, you're going to want to put it in Scratch. Scratch is subject to purging. What I mean by that is if the file system gets too full and we need to clear up some space, the data in this folder is subject to be purged. Now, we don't do it very often, and we only purge data off of inactive projects, and we will always let you know beforehand. We'll email you, we'll let you know, hey, we're running out of space, we need to clear up some data, you haven't used this project. Do you want to move this data or do you care if we delete it? So we'll always check with you first. So it's nothing, I guess, to be feared. Scratch space is accessible to all collaborators of a project. So all your group members in a specific project, this is where you're going to be sharing your data in the Scratch area. These are the two paths for Scratch on Trident and on Pegasus. They're a little different. And the final one is projects. This one does not come included with the allocation, and it's an annual fee. You can get up to 10 terabytes, and it specializes with both active and passive data. So you can run jobs from this project storage, but it can also be used to passively store your data, unlike Scratch that may be subject to purging. So this is not subject to purging. Similar to Scratch, it's accessible to all collaborators, and paths are specific depending on your project. Okay. Oh, next, let's use the software. So we provide software on Trident and Pegasus through software modules. You can access these modules through module commands, and we're always installing new software, updating existing software. We have a guide for it directly in our docs here, but I'm just going to quickly go over the most used software module commands that I see. Now let me open up my terminal here. Okay. So let's say I want to get a full list of software modules on Trident. I'm going to type in module, avail, and enter. And you get a pretty good size of what is available on this cluster. Now, this is a lot of information. Let's say I want to specifically find what versions of R we have. I will type in module, avail, R, and then I'll get the different R versions. Okay, I want to load R 4.1.0. I'm going to type in module, load, R 4.1.0. Okay, now I want to see a list of all the modules that I have loaded to make sure that that got loaded. I'm going to type in module list. And here you get a list, and R is ready to use now. The software modules handle all the environment variables, the library and executable paths for you, so you don't really have to worry about any of that. All you got to do is run that module load command, and the software will be ready for use. Okay. Okay, so now let's talk about LSF. This is how you're going to be processing your code. Essentially, when you log onto Trident, you land on the login node. You want to use the resources of these compute nodes in order to process your job. And how do you do that? You're going to submit your code to the LSF scheduler. The LSF scheduler's job is to view the requirements of your code based on a script you make, and then it assigns your job to one of these compute nodes so that it can use its resources to process your code. Both Trident and Pegasus employ the LSF scheduler. One very important thing to stress is please do not run any code on the login node, like, processing R jobs, Python programs. All jobs should be submitted to the LSF scheduler. The login node has a limited amount of memory, and it's shared across all our users. So if someone starts running a really big process, for example, that takes up memory, it's going to slow everyone down or might even crash the login node. So please don't run code on the login node. Always submit it to the LSF scheduler, and we'll go into detail about how to do that. So these next few slides are a demo on how to use LSF. I'd rather show you on the command prompt, though. Let me see if I can make this a little bigger.
You can increase the text size.
Yeah. Some properties maybe. Fonts. 20 maybe. Okay, is that kind of better? That looks a little better. Okay. So first thing I'm going to do is I want to run this job in my Scratch space. So I'm going to move to my specific project's Scratch space. Okay. And let's take a look at what's in this folder. So I got a couple of things. I got some CSV data. I've got my script that I want to run. It's just a basic R script. And then I have this .job file. This is my LSF job script. This is what I will submit to the scheduler so that it can assign resources to my job. Let me just open up the R file. It's very simple. I'm just loading a library, and then I'm reading the first 5 rows of the CSV file. Just a basic R script. Okay, let's take a look at the LSF job script. So it's comprised of 2 parts. Can you see it? Oh no, it's dark.
Just highlight.
Nope. All right, let me see if I can. It's a lot more clear on my computer. Let me see if I can change the font. Yeah. Oh, colors right here. Oh, background. Yeah, that's a good idea. Where can I do that? White, no.
White's all the way to the side. Yeah, keep going.
Let me see.
Yeah.
Okay, that's kind of better. So the first portion up here, followed by preceded by all these B stubs, these are the parameters for LSF. This is what LSF looks at when it runs your job. Down here is where you are executing your code. So we'll just go through it really quickly. You have J, which is the name of your job. P is your project ID. This is very important to put because this is how LSF will submit your job and how we will track your job resources. Without it, you probably won't be able to submit a job. -O and -E, this is output for LSF. and error log files. So if anything goes wrong with the job, it's going to be in here. W is going to be your wall time. This is how long this is the max time that your job will run for. So it's not saying that it will run for an hour, but it will run up to an hour and then it will kill it. Q is the different queues. We'll go over this in the next section, but there's different queues of nodes on Trident and Pegasus for different purposes in terms of computation. There might be a parallel queue, normal queue. For this example, I'm just using a normal queue because it's just for general computation. N is the number of cores we're requesting. This is a serial R job. I'm just going to request one. And capital R usage mem is the amount of memory I'm requesting per core. So this is in megabytes. This reads 2,500 megabytes or 2.5 gigabytes per core. And then after that, I'm loading an R module and then running my R script. Okay. Oh, am I inserting? Okay. So now we're going to submit the job using the B sub command, followed by greater than symbol, and then the job script name. Okay. Just gonna run this a couple times. Okay, so a couple of things here. I first submitted it up here and I got assigned a job ID. This job ID is very important. It's very handy for us admins when we're trying to troubleshoot your jobs. And it's also handy for you to see the history of your job. So it's important to keep note of that. And you'll see which queue it's submitted to. After that, you saw me execute this, I apologize, this bjobs command a few times. Bjobs is how you're going to see the status of your running jobs. You'll see the job ID, the user that executed it, status, so mine was pending for a bit, the queue it was submitted to, the host it was submitted from, the host that's working on my job name, and the submission time. So usually the status will change to running, but my job finished so quick that it completed already. So it doesn't show that for this case. But you can see that there's some more output now. We have these job IDs followed by .er.out. This is LSF output. .er is useful for any error logs. Let's take a look at it. It should have no errors and no errors. Perfect. Now let's take a look at the LSF output. This will detail which compute hosts worked on my job. So T70, that's the name of the machine that worked on my job. When it was started, when it completed, what my job script looked like. And more important details are at the bottom here. Here, this is the resource usage summary report. This contains the summary of how memory was utilized in your job. The one I like to pay special attention to is this delta memory. So you never want this delta memory value to be negative, because if it's negative, then that means that you didn't request enough memory for your job. So that's something to keep in mind when running these type of jobs. You want to request enough memory. How do you do that? Sometimes it really is just about trial and error. I would start with how much you think you need based on the size of your data, and then request a little more than that, perhaps. But the resource usage summary report will give you more details. And then last but not least, this is my R output from my R script, which is just displaying the first 5 rows of that data set. Obviously, this could be used for more, complex compilations, but this is just to show you how you can run LSF jobs. Okay. These few slides are for your reference. We'll be distributing the presentation after this is done. So if you want to just go back and you won't have access to the space I was working on, you can reference these slides on that entire process, as well as some of the documentation we have here. I actually want to open the job script documentation rather quickly, because we have a lot of example job scripts on our docs. And you don't have to remember everything I just told you about these parameters because we have them all detailed here, what each of them mean. You can use this as a sample and change it to fit your needs. We have serial job examples, distributed jobs, parallel jobs. So there's different types of examples. I won't go too into detail about the types of jobs. That's for a later training session. But you have a lot of resources here to help you create your job script. Okay, and lastly, we'll go over the different queues. So Pegasus and Trident, they have similar queues, some minor differences. Let's look into the Pegasus queues. So here we have general for just general computation, serial jobs. Pegasus, we have a separate queue for parallel computations. Big Mem queue for jobs that require a lot of memory. Interactive queue is used for jobs that you want to interact with. So maybe you want to run a graphical job with MATLAB or RStudio or something that you want to interact with your code, and it doesn't have to be graphical. Usually when you submit a job to LSF, the work is done in the background and you don't interact with it at all. But if you want to interact with your R code, you can submit it to this queue. And the GPU queue. So some difference between Trident and Pegasus. The Trident cluster, every single node has GPUs. Pegasus cluster, it's an older cluster. There's a specific queue because only a select few nodes have GPUs, and you'll have to request access for that queue if you're using Pegasus. You can do that by emailing us at hbc@ccs.miami.edu. You'll see that email a lot in the future slides. Other than that, you can see the core limitations and the memory limitations and wall times for each of these queues, along with the description. So let's open Trident. Very similar. I think the main difference is that there's no GPU queue because all the nodes have GPUs, and the normal queue you can also perform parallel computations. So this queue kind of fulfills two queues in one. We also have a big mem queue. This big mem queue hosts more RAM than what is displayed here. It's actually like up to 1 terabyte probably of memory for this one. So it's a lot more than we have available on Pegasus. And of course, we also have an interactive queue. So depending on your computational needs, you will select a specific queue. And that queue contains nodes specialized for the type of job that you're trying to run. Down here, I also included a helpful LSF command. If you don't want to search through our docs, you can run this bqueues command on the cluster, and it gives you a list of queues. All right, so now let's talk about requesting, managing accounts, projects, group members, and some of the costs for utilizing ACS systems and services. So to request a project, we made like a kind of a workflow, the steps that you need to follow. So first thing, you have to be affiliated with UM. You're either faculty or student. If you're an external vendor, you have to be approved by, I believe, UMIT and our department. But if you're not sure about the project requirements, you can always email us at hbc@ccs.miami.edu. So before you request a project, you want to secure funding. You can either provide a UM Workday account number, which is through your PI department or your University of Miami Workday. And it's a number that's PG followed by 6 digits. Or most people apply for one of our available grants. Now, this is the link for our grants. And I'm going to be referencing a lot of links in a bit. If you need access to any of them, you can always go to our main site and hit quick links. And all the links are there. Anything you might need for advanced computing, to grants, to create an account, everything can be found here at quick links. So that's just for your reference. So these grant programs will go into more detail in another section, but they're very easy to apply for. You see the eligibility requirements. This one's for faculty. This one down here is for students, and they'll give you a specific amount of allocations so you can start using the cluster and create your project. But the important thing about all that is that once you finish applying and get approved for a grant, you're going to get a grant number through your email. It's going to look like one of these here. These are just a few examples, like EC 6 digits or AC followed by 6 digits. You want to keep that grant number because you're going to need it for the project application. So once you get your grant number, this is the form you're going to look at to apply for your project. You're going to put in your name, your KNID, your email address, name of your project. We prefer a shorter name, but you can put a project title that suits you. Project description, resource type. This is the resource you're selecting, so either Pegasus or Trident. If you're not sure which resource to select, email us at hbc@ccs.miami.edu and we'll help you figure that out. This isn't the end-all be-all resource. You can use the same allocation you receive from your grant for either Trident or Pegasus. So it's not like you're locked into one supercomputer. You can put a expiration time if you're only going to be using the cluster for a limited amount of time. And this is where you're going to input your grant number. So it asks you, do you have a Workday account number? You're going to hit yes. And there you're going to put whatever grant number was assigned to you. Here, it's going to ask for a description. You can just put the title of the grant. You'll have that in email as well. Is there a budget line item for IDSC resources? Usually I'll hit no. Additional information, anything special we need to know for your requirements, your project. You can put that here. Once you submit it, someone from my team will review the project, will approve it, create it, and then we will send you an introductory email that contains specifics on how to access your space on Trident or Pegasus, how to log in, how to utilize onboarding videos, your scratch path, all the information you'll need to start using the supercomputers will provide it. You also need to request an account. Requesting an account is much easier. It's very straightforward. You're just providing, basic information, first, last name, C number, KNID, email, campus and college and department you belong to. For project ID here, if you're doing this for a new project, you can put like an abbreviated name of your project title. This will be like your project's code name. If you're looking to join an existing project, you have to contact the group leader of that project and get the project ID from them, and you can input it here. And again, if you're not sure how to request an account, just email us, hpc@ccs.miami.edu. Group member management. How do you add and remove group members from your project? Email hpc@ccs.miami.edu. Just give us your project ID and the KNID or C numbers of the members to be added, and we'll handle that for you. All right, so let's talk about the cost of using ACS systems and services. So this fee schedule is available online in our quick links section. So we calculate our usage based off of SUs, what we call service units. When you apply for a grant, you are rewarded a specific amount of SUs, and we use this whenever you run a job or use storage, it counts towards that SU allocation. So as like an example, when you run a job and you're requesting CPU per hour or you're requesting RAM per hour in a job, just know that that's going to cost SUs. If you're leaving data in your scratch space, your project's assigned scratch space, that's going to cost SUs. If you want specifics on quotes and costs or how much your project is utilizing per month, email us at hpc@ccs.miami.edu and we will get that sorted out for you. Same goes for GPU service units. It's the same principle as those CPU service units I just described, but with GPUs. We have advanced consultation that Elvis went over briefly at the beginning. This is just more of a high-level consultation to help you design and implement, solutions to optimize your code, For anything long-term, you'll probably want to consider advanced consultation. We have the GPFS storage. So this is the project's storage we mentioned before. Usually you're allocated 10 terabytes and you're charged a specific rate per terabytes, but it is an annual fee. You have cost-effective storage. This is the one that's not connected to the supercomputer. Charged at 300 annual fee flat. You get 10 terabytes, but this is purely for archival storage. This won't be connected to the supercomputer. You won't be processing data. So that's just to keep in mind if you just need storage. Big data and data analytics is another form of consultation that we have for bioinformatic analytic projects and consultations of that sort. We also have consultational fees for our systems and data engineering group. Anything that involves engineering development projects, computational support, software licenses, specifics and analytics, you can contact them at idis.miami.edu or hbc@ccs.miami.edu. All right, so you've got all that information and you might need help. Where would you start? You should first go to our user documentation. That's the docs that I have been referencing this entire presentation. If you click that there, acsdocs.readthedocs.io, no need to memorize that whole link because you go to quick links and it's going to be there. Anything you need in terms of links, it's going to be here at quick links. You look documentation and user guides. So all the information I just went over, Trident, Pegasus, connecting to the cluster, transferring files, storage, running jobs, LSF, all that information can be found here in our user documentation. We also have the Linux guide here, specifics on our services and policies. We also have, if you don't want to go through all that information, you're just trying to quickly get onboarded, we have onboarding videos. It's a playlist on YouTube that's composed of 10 videos, but they're all very short. I think the longest one is maybe 2 minutes. But we designed it as a means to quickly get people to start using the cluster as opposed to, kind of dredging through all the docs, but it's still good to reference them if you need more specific details. So you can also submit tickets to hbc@ccs.miami.edu. I'm not kidding. Anything you possibly might need, you just email that email and we will help you with it. You need to request an account or project, you email that. LSF job issues, software issues, email that. Quotes, grants, anything, email hbc@ccs.miami.edu. So specifically, if you are having issues with software or LSF jobs, this is just a sample of an automated email you receive when you send a ticket to this email. And these are details that you want to include so that we can help you resolve the issue more quickly with like an LSF job. Which cluster are you working on, Trident or Pegasus? The job ID, very important from before when I mentioned when you submit a job, you get that job ID. You want to make sure you keep that. Modules you have loaded, paths to your job script or output files, whether your job ran before, if anything's changed, if you include all that information, the turnaround time for these tickets becomes a lot better. And if you need general information, you can visit our main idisc.miami.edu homepage. /advanced computing for specifics on our group has a lot of information that we went over during this presentation. I'll open it up very quickly. We've got our general information up here of what we provide. We have quick links, contact us. We have the different data science services that we provide that we went over at the beginning of the presentation. And once again, I would like to stress quick links. Everything you need in terms of links is in quick links. And that's all I have. I'll pass it off to Elvis now.
All right. So let's finish off by talking about grants. Nick already has shown some of the grant programs available through IDSC. I just going to, I guess, present where you can find specific information regarding those. So there's the link in the slide. I would like to perhaps, talk about the grant programs available to students who are going to be new users of advanced computing. So we have the advanced computing grant for students. You can see, you can visit the link. You can visit the page and figure out how you can apply to that. For faculty, there are there are a couple of grant programs available. There is the early career grant program that new faculty can apply to. Might as well, I guess, just show you because I was going to talk about it through. This is the link to the Advanced Computing for Students grant that students can apply to. There is for faculty the Early Career Researchers Award, as well as a program for expanding the use of data science in collaborative research. Well, I mean,
Yeah, expanding using comes with funding, $20,000 and computing. The early career is, if you are new faculty and you wanted to try your hands on machines, that's early career. Same thing for students. Students can explore the machine, just get to know. That is the student grant, but once they wanted to get into research school, that is the faculty responsibility to figure out how they going to cover it.
I'm struggling with this computer. Let me just go back to the PowerPoint. I'm trying to switch to the PowerPoint. I'm trying to switch to the PowerPoint. But essentially, you have those those grant programs available to faculty, and then periodically you also have a call for proposals for specific research. I remember last year there was a call for a proposal where they invited proposals from faculty who sought to use or develop large language models. And then for faculty as well, I think there's a bridge program that faculty can initiate on behalf of students who need service units to complete their research projects. We have shared links to the pages where you can find more specific information. And then to finish off, I'm just going to show select collaborative projects between IDSC and a variety of schools here at UM, as well as, external organizations. And then that's it, really. Do we have time for questions? Should we have a Q&A?
Yeah, there's some questions.
Oh, okay.
There's a couple questions in the chat.
Oh, okay.
So one question is about our student. Well, first in order, how can we transfer files from
from Box to Pegasus.
You have a way to transfer? Or maybe it's easier for you to go there.
Yeah.
I will figure that out. Then we'll get some happening.
So I believe the question was from Box directly to Pegasus. So, yeah, usually you can run commands like rclone from that machine and transfer that data in a load, but you can email us and we can help you set up a data pipeline in order to get that data from your side to our cluster. But the answer is usually you'll rclone that data. I think that's the most straightforward way. We might have, yeah, there's some documentation definitely on that if you check out our public docs.
Another question about RStudio.
Yeah.
Would you use RStudio?
So there's, I suppose, two versions of RStudio. We host both on Trident and Pegasus. Trident is an RStudio server, so there's a URL. You just open the URL in any browser, and you sign in with your credentials, and you start using RStudio. It's a little bit of a lower version. We also host RStudio on Pegasus, but it's not a server. It's RStudio desktop, and we launch it through an interactive job. So it's like kind of like your own personal session of RStudio. You launch an X11 session and run an interactive job invoking RStudio and loading the RStudio software module. We can go into more details about how to run interactive jobs in the future training session, but we have examples of how to run RStudio as a software module on our documentation as well. But you're also free to install any packages you may need, or if you're having trouble installing packages, you email us and we'll help you get that sorted out. Yes.
So for students, when they apply for a grant, how long that grant stays and like what computational power they get?
So usually students apply for
Repeat
the,
the question.
oh, I'm sorry.
No, repeat the question because it will.
Oh,
what they
yeah.
said.
Sorry. Do you want to pass the microphone or? So the question was, for students, how long does their grant allocation last and what resources do they have access to? Usually we'll see students applying for the Advanced Computing Rewards Grant. The turnaround time on that is fairly quick and they're fairly lenient with approval. You'll get 20,000 service units and you have access to both Pegasus and Trident, RStudio, Jupyter Hub, any services you might need on the supercomputing clusters, you have access to that. The scratch space, home storage, all the software. The only real difference is the amount of service units that you get allocated. So 20,000, which is quite a good amount to get started. We know students might not have the budget. So we also offer like a bridge award. So let's say you run out of service units, but you haven't quite completed your research yet on the supercomputers. We can work with you and grant you maybe an additional allocation to help you finish that off.
So there's no time limit as long as I still have those. Like,
Exactly, yeah.
credit.
Right. So there's no unless you yourself set it, which most people don't, there's no time limit. You can use it as long as you want, as long as you have the service units to use it. Are there any other questions? Oh, yeah.
I had a question about using our studio and using our scripts that we maybe test out on our own machines, and then
Mhm.
we can just simply import those scripts as an R script into Trident or Pegasus to then run.
Yes.
And if we have it as maybe a Porto or R Markdown document, is that also work, or no, does it have to be in an R script on its own?
As long as I suppose it can be executed as a program. Usually we execute ours as like R scripts, and then you reference that in the LSF job script. I'm not entirely sure about our markdown files. You can always try, referencing that in the job script, try calling it like you would normally call it in the terminal. But I don't see why it shouldn't work, but it's definitely something you can test out.
It's maybe different, like from Windows to Linux and again Mac to Linux.
Right.
So you need to have some spaces and some tabs will be adjusted when you are converting
Right.
the files from Windows or Mac to the Linux. So definitely we need to cross-check those kind of things.
Yeah, so that's a really good point. So when you're creating your scripts on your local machine and you're transferring that to Trident or Pegasus, the operating systems are different. You might be working on a Windows Mac. Pegasus and Trident run off of CentOS Linux. So, some spacing or some tabs might cause your script that you transferred to not be compatible. There's a handy command that you can use. It's called DOS to Unix, right? And then you pass the file name with that command and it just changes the architecture of that file to work with Linux. Let me see if I can actually find that. Let's see. Let's see, DOS Unix. Okay, so I don't think we have an example in our docs, which we should probably change, but if you just Google it, you can see kind of an example, Let's see. Not a good example. Here, let me see if this Linux man page. Yeah, so essentially this is the syntax for this command and it's available on both supercomputers. You run DOS to Unix and then, if you want to provide options, you can, but usually I will just put the name of the file and then it will convert that file to be compatible with the Trident and Pegasus operating system. Is there any more questions on Zoom or? Yes. Yeah, no worries. Absolutely.
One issue that potentially use this for is image analysis. So microscopy images and cell segmentation. Have you done any work with individuals who've done something similar to that? So they upload a logical image. In my case, it's going to be multi-channel fluorescent images, and then allow a program that runs in the Anaconda environment or Python environment
Yes.
to then cell segment based upon the boundaries that
Yeah.
are established by the immunofluorescence.
Definitely. We've had some individuals work on similar projects. We have Anaconda as well available on both clusters. If nothing, is available maybe on as a software module or you need specific libraries or packages, you can create an Anaconda environment on both clusters and that way you have more control over what packages and versions you require and dependencies like that.
I have a very
Oh.
small question.
Yeah.
When I work on Windows, I use WinSCP to transfer between files.
Yes.
Like you said, Filesystem, I've never tried that.
So you can use WinSCP as well.
Totally fine, but when I work with like Mac,
Mm-hmm.
like I have to loan a laptop to work from home because it doesn't let me.
Right, right.
So I couldn't do the WinSCP, but one of the person I know told me to try CyberDuck. CyberDuck is a software that I use, so FileZilla works on
Yeah.
Mac too? Okay.
Yeah, I use FileZilla and on my Mac personally
I have several questions from the chat in Zoom. So I'm gonna read it out for you.
Sure,
First
yes.
question is from Elena. She says, is there a way to transfer files directly from bots to Pegasus without downloading to a computer first?
Hmm.
Yeah, we talked. That was.
Yeah. So, that was the first question, I think. Yeah, I think that was the solution that was utilization of our clone and will help you set up a specific data pipeline to fulfill that need. I think we were a few questions down in the chat.
Yeah. Can we do analysis on health data that includes protected health information like dates? This is from Raymond.
No. So yeah, we don't usually host HIPAA, any HIPAA records. That's sensitive data. Um, it can be done via collaboration. Maybe we can meet with you and see what you need and spin up a separate virtual server that's more secure. But we would need to discuss that in more detail because HIPAA records are very sensitive.
Alex says, if Tritone is a new cluster, would you be phasing out Pegasus at a certain point?
So there's interesting differences between Trident and Pegasus. Trident is rather new. It has, more RAM, more cores, more powerful nodes, but it also utilizes a slightly different architecture from Pegasus. So Trident uses what's called Power 9. It's very good for data intensive workload, big HPC problems, things like that. However, not all software is supported on that architecture. That's where Pegasus comes in. Pegasus runs off of what we call x86 64. This is a more commonly used, more widely supported architecture. So usually what might happen is that you might use Trident, and then you find that the software that you're trying to run is not compatible on Trident. So then you would defer to Pegasus instead. It's not to say that one is worse or better than the other. It's just used for a different scenario. But definitely there's that architectural difference that one should keep in mind.
Dima says, you said we need Miami wireless or secure getting Wi-Fi to connect to the account. What about the students in main campus? We have only access to KNet wireless. How do we
Right.
get access?
So you should now have access from CanesNet from the last time I spoke with UMIT, but that is like I know that's like an ongoing struggle that we've had with some of our student users because of the new network change. I'm sure that you can connect to the supercomputers directly from CanesNet, but maybe not from some of our resources, like maybe the password reset page or maybe the IDSC page. I'm not sure because UMIT kind of locked that area down quite a bit. I'm not entirely sure, but I know that there's some limitations with the CanesNet, but you should be able to directly access the supercomputers. But we're still working that specific issue out. That's temporary right now.
Last question here in the chat as of right now. Are there any general guidelines for use of Jupyter Hub versus the LSF for software development in R or Python? This is by Richard.
So we do have specific guides for software and how to use that software on the public docs. If you look at the Pegasus and Trident sections, we've made, sections on how to use Jupyter Hub on Trident or how to run an R script or Python or OpenMPI. So there's different sections for that software and different guides. And if you're still not sure after that, you can always email us and we can definitely consult with you. Like, I know we talked about advanced consultation for a price, but the basic consultation, we really try to work with you to get you started on using that software on the clusters. Yes.
Can you explain more the difference between the home directory and the scratch directory?
Yes. So home directory is the home folder that you first log into. That is something that you have access to and you alone. You can install software if you need to. You can hold a small amount of data. It's like 250 gigabytes, so more like a pretty decent chunk of data there. The Scratch is a folder that is shared with your entire project. So all the members of your project will have a single Scratch space. So let's say your project is called RNA sequencing. The path to your Scratch is going to be Scratch RNA sequencing. And all the members of your project have access to that folder. And that's where you can share all of your data. So you can't do it from home because home is personal, but you can do it and share and collaborate through the Scratch directory. It also has the 2 terabytes of data in that area, and that's where you're going to want to hold all the input parameters and output data from the jobs that you run on the cluster.
These containers. When you can go there.
Yeah. So we've actually, Rajesh might want to answer this one, but we've been in development of like Obtainer.
It will be like input data need to be passed for the script to run the application as a temporary storage. And home is always your storage for the files at the same time to install your software kind of applications or softwares. And you can run the containers also. Recently, we have done with the Obtainer kind of
Yeah.
thing. So we done different kind of applications. We will push the documentation into the public. We have implemented all those kind of
But they're run through a framework called Aptainer.
Yeah.
And you can convert Java files to a
Dog is not
compatible
allowed.
format, and then you can run them through Aptainer.
You had a question? Yes.
Yeah, so I'm a graduate student from IDSC department.
Mhm.
Right now, I'm doing on the graph neural network training, so I'm using my CPU for now.
Oh, okay.
But I want to use like GPU, so like, how can I start doing it?
So which cluster are you using right now? Or are you on one of the clusters yet? I'm sorry, I didn't hear that
No.
first part. No? Um, so what you're gonna want to do is send an email, and then we can guide you on applying for one of the grants, right? So we can get you onboarded onto either Trident or Pegasus. But if you want to do specifically GPU work, I would recommend Trident if it's compatible with your software because they have 2 GPUs per node and it's more powerful than the ones we have available on Pegasus. But GPUs are open to everybody on Trident. But yeah, if you send us an email, we can get you set up with that. Yeah, you're welcome.
Who do you work for?
Dr. Mendo Hamadu.
Who?
Mendo Hamadu.
Where would we put the docs, or the slides?
Oh, that's a great question. I will probably be sharing this with the video recording that we will have. I'll probably share it on Drive, maybe with the participants, but we have a list of everybody. We'll be sending the presentation to everybody. I think that's it. Well, thank you for being here. We really appreciate it.
Thanks very much.
Thank you. Thank you, sir. Yeah.
Good time.
Yeah, good time. Yeah, we got through it.
Yeah. Right on the money.
All right.
Turn off recording and then.
Oh, here, stop sharing. I don't know how to